Today I'm just going to have you look at one more example. We're going to go through the different parts of the example. The first part is to complete the table. So we're going to know that the concentration C of a chemical in the bloodstream T hours after injection into the muscle tissue is given by that function. Complete the table and use the table to approximate the time when the concentration is the greatest. Again, you're going to want to use your graphing calculator. So we're going to go into our graph button. We're going to hit our y equals. If you don't have your graphing calculator out right now, please grab that. Alright, and you should have that now. So we're going to have 3x, and I'm going to go ahead and put mine in parentheses on my calculator just to make sure it reads it as 3x on the top, divided by, in parentheses, 27 plus x to the third. Again, I have to use the x because I don't have a t button on my calculator. And we're then going to go into the table part of it, and we're going to start to ask it questions. So what's happening at 0? Well, when I type in and ask what's going on at 0, I find out that I get 0. When I type in 0.5, I get 0.055. When I type in 1, I get 0.107. I'll type in 1.5, I get 1 or 0.148. When I type in 2, 0.171. When I type in 2.5, 0.176. And then at 3, I get 0.167. So it looks like it was increasing all the way up to here, and then it starts to decrease. So the concentration seems the highest. The concentration seems highest at 2.5 hours. That's just strictly by looking at the table and the graph. Now we're going to go into this problem. It's the same problem, but we're going to do it a different way. So that was using numerical values. Now we're going to look at it graphically. You guys can look at the graph by selecting graph, and then the graph will appear on your graphing calculator. And what you will notice that it is something similar to what you just saw on the table. It was increasing until it gets to 2.5-ish, and then it starts to decrease. The last thing we're going to do is we're going to look at that analytically, which means we're going to use our calculus, and that means that we need to take the derivative so we can find the value where it's increasing, or that critical number where it's changing from increasing to decreasing. So the derivative would be, we definitely have to use quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom, all over bottom squared. From there, I'm going to go ahead and simplify. You guys are going to probably have to spend a little bit, well, I'll write some things down here, I guess. I've got 81 on 3t cubed from distributing this way, minus 9t cubed, all over my 27 plus t cubed squared. This then gives me 81 minus 6t cubed over 27 plus t cubed squared. I want to find those critical numbers that are going to happen, so I am going to plug in 0 for my C prime. So I get 0 equals, and I'm concerned about what's going on at the top. So C prime equals this 81 minus 6t cubed. I can take out a 3. The 3 doesn't mean anything then, and I can take and set the 27 minus 2t cubed equal to 0. Moving the 2t cubed to the other side, I get t cubed is equal to 27 over 2. And then what I need to do is cube root both sides. Well, I get the cube root of 27 over 2, which is approximately 2.38 hours. So this is going to give me my exact answer, where the graph and the table are just giving me approximations.